In the vast expanse of our solar system, a celestial ballet unfolds, captivating our imagination. Giant Jupiter, a ruler of planets, holds court with its entourage of moons, each with its own story to tell. Among them, Europa, a shimmering jewel of ice, beckons us to unravel its secrets. Its surface, a tapestry of cracks and ridges, hints at a hidden world beneath. Europa's gravitational dance with Jupiter and its neighboring moons generates tidal forces, creating internal friction that warms its core. This internal heat is thought to melt the ice below the surface, forming a vast global ocean, potentially harboring conditions suitable for life. The possibility of finding life beyond Earth, even in our own cosmic backyard, fills us with wonder and excitement. Europa stands out among Jupiter's moons as a place of both beauty and mystery. Its surface, a canvas of white and pale blue, is remarkably smooth, with few impact craters, suggesting a young and active geology. Long, reddish-brown streaks crisscross the surface, evidence of the internal churning and resurfacing that make Europa so intriguing. These surface features are our windows into the hidden ocean below. Scientists believe that the cracks and ridges are formed by the constant stretching and squeezing of the ice shell as Europa orbits Jupiter. The reddish-brown material may be salts and organic compounds brought up from the ocean, offering tantalizing clues about the chemistry of this hidden realm. The possibility of a vast salty ocean hidden beneath Europa's icy shell has captivated scientists for decades. Could this hidden ocean harbor life? The presence of water, a source of energy, and the right chemical ingredients are the essential ingredients for life as we know it. On Earth, life thrives in the most extreme environments, from the depths of the oceans to the boiling hot springs of Yellowstone. Europa's ocean, warmed by tidal forces and potentially rich in nutrients from hydrothermal vents, could provide a similar haven for life to emerge and evolve. The quest to find out is one of the most compelling scientific endeavors of our time. Europa, a celestial marble, hangs in the blackness of space. Its surface, a dazzling expanse of white and blue, reflects the distant sun's light. It's a fractured, chaotic landscape crisscrossed by dark lines. These lines tell us that Europa's icy shell is dynamic, shifting under Jupiter's gravity. This movement generates heat, warming the moon's interior and revealing a hidden ocean below. Imagine an ocean, not bathed in sunlight, but hidden beneath a shell of ice kilometers thick. This is Europa's secret, a global ocean, dwarfing all the oceans of Earth combined. Scientists estimate that this subsurface ocean could be 2 to 3 times the volume of all Earth's water. But what kind of ocean is it? Scientists believe that Europa's ocean is salty, perhaps even more so than Earth's oceans. The salts, likely sulfates and chlorides, could come from the moon's interior. This salty ocean in perpetual darkness may seem an unlikely place for life, but on Earth, life thrives in the most extreme environments, giving us hope that Europa's ocean, too, could be teeming with life. Europa's ocean is not a stagnant pool. The moon's elliptical orbit around Jupiter, combined with the gravitational pull of its neighboring moons, creates powerful tidal forces that squeeze and stretch Europa's interior. This constant flexing generates heat, keeping the subsurface ocean liquid and driving geological activity. This tidal energy is thought to fuel volcanic activity on the ocean floor, similar to the hydrothermal vents found on Earth. These vents spew out hot, mineral-rich water, creating chemical gradients and potential energy sources that could support life. The dance between gravity and heat creates a dynamic environment, potentially fostering the conditions necessary for life to arise. The presence of water is essential for life as we know it, but it is not enough. Life needs building blocks, the molecules that make up cells and carry genetic information. On Earth, these building blocks are carbon-based, and scientists believe that the same could be true for life on Europa. Observations of Europa's surface have revealed the presence of organic molecules, the building blocks of life. These molecules could be delivered to the surface from the ocean below through cracks in the ice or by plumes of water vapor that erupt from the surface. The presence of these molecules, combined with the potential for liquid water and chemical energy, makes Europa one of the most promising places in our solar system to search for extraterrestrial life. In the cold, dark depths of Europa's ocean, far below the reach of sunlight, a different kind of chemistry might be at play. Here, in the absence of photosynthesis, life, if it exists, would rely on chemosynthesis, deriving energy from chemical reactions rather than light. This is not as alien as it sounds. On Earth, in the deep ocean, where sunlight never reaches, life thrives around hydrothermal vents, drawing energy from the Earth's internal heat. Europa's ocean, warmed by tidal forces, could host similar hydrothermal vents, spewing out hot, mineral-rich water. These vents could provide the chemical ingredients and energy sources necessary for chemosynthetic life forms to evolve. Imagine creatures unlike anything we've ever seen, adapted to this alien environment, their bodies glowing with bioluminescence, illuminating the eternal darkness of Europa's ocean. The search for life beyond Earth is a search for the familiar in the unfamiliar. We look for signs of life as we know it, based on the only example we have, life on Earth. Life is resilient, adaptable, and thrives in extreme environments. From Antarctica's frozen deserts to Yellowstone's hot springs, life finds a way. Europa's ocean might be surprisingly hospitable to life. Liquid water, organic molecules, and energy sources create a tantalizing possibility. Beneath the icy shell, life may have evolved uniquely. Discovering life on Europa is a compelling target for exploration. The exploration of Europa's ocean presents a formidable challenge. The ice shell, kilometers thick, stands as a barrier between us and this potentially life-harboring environment. But the allure of discovery is too strong to resist. Scientists and engineers are developing innovative technologies to overcome these challenges and unlock the secrets hidden beneath the ice. One concept involves a lander that would melt its way through the ice, deploying a submersible to explore the ocean depths. Another envisions swarms of miniature robots released into the ocean through cracks in the ice, transmitting data back to Earth. These missions, though still in the planning stages, represent our ambition to reach out and explore the unknown, driven by the possibility of finding life beyond Earth. Section 4. In search of a signature. The search for life on Europa is not just about finding creatures swimming in the ocean, it's about detecting signs of biological activity, what scientists call biosignatures. These could be chemical imbalances in the ocean's composition, complex organic molecules, or even faint signals of biological processes. Future missions to Europa will carry instruments capable of analyzing the composition of the ocean, both from orbit and directly on the surface. They will look for specific molecules and isotopes that could indicate the presence of life or the processes that support it. The detection of even the faintest biosignature would be a monumental discovery, forever changing our understanding of life in the universe. Section 1. Past glimpses. Our journey to understand Europa began from afar. In the 1970s, Pioneer and Voyager offered our first glimpses of this icy moon. The images, though grainy, revealed a world crisscrossed by mysterious lines. These early missions sparked our curiosity. Galileo, orbiting Jupiter from 1995 to 2003, provided a closer look. Galileo confirmed Europa's hidden heart, hinting at the possibility of life. Section 2. The Clipper's Promise. Now, a new mission is being prepared to unveil Europa's secrets in unprecedented detail. The Europa Clipper, named after the swift and agile ships of the 19th century, is set to embark on a journey to this intriguing moon in the 2020s. This sophisticated spacecraft, equipped with a suite of advanced instruments, promises to revolutionize our understanding of Europa. The Clipper will orbit Jupiter in a highly elliptical path, making repeated close flybys of Europa, dipping in and out of Jupiter's intense radiation belts. This daring maneuver will allow the spacecraft to gather detailed data about Europa's surface, its magnetic field, and the composition of its tenuous atmosphere, all while minimizing its exposure to radiation. Section 3. Piercing the Veil. One of the Clipper's primary goals is to study Europa's icy shell in detail. The spacecraft will use ice-penetrating radar to peer beneath the surface, mapping the thickness and structure of the ice and searching for potential water plumes erupting from the ocean below. These plumes, if they exist, could offer a direct glimpse into the composition of Europa's ocean without the need to drill through the ice. Imagine the excitement of detecting a plume erupting from Europa's surface, a geyser of water vapor and organic molecules reaching out into space. The Clipper will be ready to analyze the composition of these plumes, searching for those telltale signs of life, those chemical imbalances that betray the presence of biological processes. Section 4. A symphony of instruments. The Europa Clipper is more than just a single instrument. It's an orchestra of scientific tools, each playing its part in unraveling the mysteries of this icy moon. Cameras will capture high-resolution images of the surface, revealing details never seen before. Spectrometers will analyze the light reflected and emitted by Europa, determining the composition of its surface and searching for signs of organic molecules. A magnetometer will measure the strength and direction of Europa's magnetic field, providing clues about the depth and salinity of its subsurface ocean. The data collected by these instruments will be painstakingly analyzed by scientists back on Earth, piecing together the puzzle of Europa, revealing its secrets and bringing us closer to answering the question, are we alone? Section 1. A universe of possibilities. Imagine the moment, the headline flashing across the globe. Scientists confirm life on Europa. A discovery of this magnitude would be a paradigm shift, a turning point in human history. It would shatter our perception of being alone in the vastness of space, proving that life, even in a form different from our own, can exist beyond Earth. The confirmation of extraterrestrial life, even microbial life, would ignite a firestorm of scientific inquiry. Suddenly, Europa, once a distant icy world, would become the most sought-after destination in our solar system. The race would be on to learn everything we could about these alien life forms, their biology, their evolution, their very existence in a world so different from our own. The discovery of life on Europa wouldn't just be a scientific triumph, it would be a cultural phenomenon, capturing the imagination of people all over the world. Children, gazing up at the night sky, would no longer see just points of light but potential cradles of life, each star a sun, perhaps orbited by its own Europa, teeming with unknown creatures. This newfound knowledge would fuel a renaissance in science education, inspiring a new generation of explorers, engineers, and dreamers. We might see a surge in students pursuing careers in astrobiology, planetary science, and aerospace engineering, driven by the desire to unlock the secrets of the universe and search for life beyond our planet. Section 3. Our place in the cosmos. The discovery of life on Europa would force us to confront profound questions about our place in the universe. If life can arise independently on two celestial bodies in our own solar system, then it stands to reason that life could be abundant throughout the cosmos, a universe teeming with possibilities. This realization would have profound philosophical and theological implications. It would challenge our anthropocentric view of the universe, reminding us that we are not the center of creation, but rather part of a grand cosmic tapestry, woven from the fabric of stars, planets, and the very essence of life itself. Section 4. A new perspective. The search for life beyond Earth is a quest to understand our origins and our place in the universe. Discovering life on Europa would remind us we are not alone. The universe holds infinite possibilities. Our journey of exploration has only just begun. This perspective fosters unity and shared destiny among humankind. Our differences pale in comparison to the vastness of the universe. Section 1. Europa awaits. Europa, that icy moon dancing around Jupiter, holds the potential to unlock some of humanity's greatest questions. We have journeyed from the early glimpses of Pioneer and Voyager to the anticipation of the Europa Clipper mission. Each image, each data point brings us closer to understanding this enigmatic world, and the secrets that lie beneath its frozen shell. The possibility of a vast global ocean, perhaps teeming with life, is a powerful motivator. It drives us to develop new technologies, to push the boundaries of exploration, and to challenge our understanding of the universe and our place within it. Europa awaits, a silent sentinel, holding its breath as we prepare for our next bold steps into the unknown. Section 2. Our Cosmic Journey. The exploration of Europa is not just about this one moon, it's about our desire to explore and seek answers to the biggest questions of our existence. Are we alone in the universe? These questions drive us forward, fueling our curiosity. Our journey of exploration is a journey of self-discovery. The cosmos beckons and we answer the call, filled with wonder and open to infinite possibilities.